Welcome to section 5.2. We're working with solving trig identities. And so all of the identities that we did in section 5.1, if you don't know them by now, please have that notes packet out so that you're ready. You have them as a reference to go through. I'm going to skip the intro questions. We're actually going to start with warm-ups for those two tomorrow. But I at least want to look at the guidelines. Take a look at page 382 and look at those. The most important one to me by far is the fact that you have to try something. You should never leave a question blank. No matter what, give it a shot. Try anything that you can. And that's going to be kind of our big way of going through. Now, like we did in section 5.1, 5.1 was a little harder because it didn't tell you where to end. In this case, we're trying to tell you get it equal to sine squared in number 1, like we did in chapter 4. And so here's what I'm going to do. I'm going to look and draw a line down, and I want to work with the hardest side. Now, obviously, sine squared is the easiest. My goal is at the end to get that sine squared equals sine squared. Okay, so I'm going to look at the side on the left because I think that's the worst. What I do know is there's an identity with secant squared and 1 that hopefully can help me out. And what I'm going to do is I'm going to look at this idea that this secant squared is the same thing as the tangent squared plus 1. And if I look at the tangent squared plus 1 is the same thing as secant squared, then when I subtract 1, hopefully something will help work out there. And if you take a look, the 1's cancel out. So what I'm left with is that the tangent squared over the secant squared. And I'm going to rewrite this because I want to get back to sine. And so I'm going to rewrite tangent and secant with things as sine and cosines. So the tangent squared is sine squared over cosine squared. And if I divide that by secant squared is 1 over cosine squared. Pardon me. Now taking a look at this, what I can do is instead of dividing by a number, I can multiply by its reciprocal. So the sine squared over the cosine squared, if I multiply that by the reciprocal of the denominator, so cosine squared over 1, you'll notice that my cosine squareds cancel out. And so what I have left then is that sine squared equals, and basically you can draw that this comes right back down, sine squared. And so if you take a look at this, you'll notice again the goal was to get this side equals this side. And I did that. And what I try to do in this case, we looked at the fact that 1 plus a tangent squared equals the secant squared. And this was kind of the big thing that got us started, is we used this Pythagorean identity to replace the secant squared that was on top in hopes that this 1 would somehow go away. So that's the idea in number 1. In number 2, if you look, I'm going to try and add these two fractions together. And obviously, I think the fractions are the worst side. So I'm going to draw my line down. And what I'm going to do then is find a common denominator. So I'm going to multiply this first fraction by 1 minus a sign. And I'm going to multiply the second fraction by 1 plus a sign. All right, so here's what I have. In the numerator, I have 1 plus the sign, plus I have on this side 1 minus a sign, all over 1 plus a sign times 1 minus a sign. Throw in my theta there. Okay, now you could FOIL that out. Right now I'm going to leave it. Because here's what I noticed. A sign cancels with a negative sign. So in the numerator, I have 2. In the denominator, I'm actually going to FOIL this. So 1 times 1 is 1. If you notice, you get a negative sign and a positive sign, which would cancel. Sine times negative sign is a negative sine squared. And this identity is another one of our Pythagorean identities. And 1 minus sine squared is the same thing as a cosine squared. Now I'm going to rewrite this a little bit different, and I'm actually going to take it over here. This is the same thing as 2 times 1 over cosine squared, and 1 over cosine squared is the secant squared. So if you look, I have 2 times the secant squared, which is the same thing as 2 times the secant squared. And so looking at this, again, you always take the worst side, the side that looks the worst, and you try to get it to look as simple as you can. Now, trick in this case, I don't know, we did 2 things. We did a common denominator. That was our first idea. And then we also used that sine squared plus cosine squared equals 1. And so we kind of used the Pythagorean identity, but first we had to have a common denominator. And so those are kind of the ideas. I don't know that I'd call them tricks, but at least ideas going through that kind of tell us, hey, this is the place to kind of go and take. Okay, so I'm going to move on to the next couple. All right, take a look. Now we have addition, tangent of x plus cotangent of x equals the secant times the cosecant. And I'm going to work with addition before I work with multiplication. So I'm going to draw a line, and again, my goal is going to be to get the right side. And my hopes is that maybe I can make that work. So I'm going to rewrite these 2 to try and get them together. And I'm going to go, because secant and cosecant talk about sines and cosines, I'm going to rewrite these as sines and cosines. So tangent is sine over cosine, and cotangent is cosine over sine. And so I'm looking at 2 different fractions. Again, to add the 2 fractions together, I'm going to make a common denominator. So I'm going to multiply the first one by sine and the second one times cosine. So here's what I have. In the numerator, I have sine squared plus cosine squared. All over my denominator is a sine and a cosine. So sine times cosine. All right, we'll take a look. What do we see? Numerator, this should be ringing a bell, because sine squared plus cosine squared is 1. So you have 1 over the sine times the cosine. And I can split these 2 up, because this should be looking, oh, hey, secant and cosecant. I'm going to write this as 1 over, and I'm going to switch my order so they're in the same placement as the one on the right. So 1 over cosine times 1 over sine, which is the secant times the cosecant. And again, I'm just going to drop this one down, the secant of x times the cosecant. Let me erase that a second and actually draw the right one. Secant times the cosecant of x. And so you end up getting, again, if you know, and I guess, I don't know, trick. We had 2 tricks. Again, we did a common denominator, and then we also did the Pythagorean identity. And you're kind of using both of them the whole way through on every single question you do. But the biggest thing is, look, if this is in terms of sines and cosines, it may be easier to go back and multiply and put everything in terms of sines and cosines also. Take a look at number 4. Number 4, you look at, okay, which one is worse? Well, adding 2 different things or having a fraction, and I think fractions are worse. So I'm going to draw my line. My goal is to get this side, secant of y plus tangent of y, also to happen on the right side. Now the problem here, I cannot split these 2 up because I have this plus or minus in the denominator. And I'm not adding 2 fractions, so I don't need a common denominator. But we talked about one like this in chapter 4, where you're kind of looking at, if you have 1 minus just 1 trig value, the best way is to multiply by the conjugate, 1 plus the sine of y, on top and bottom. And so we're using the idea of kind of a conjugate with trig values. And when I do this, I'm going to multiply. Okay? Now, I'm going to leave the multiplication separate in the numerator for just a second. Cosine of y times 1 plus the sine of y, all over, and I'm actually going to FOIL the denominator. So 1 times 1 is 1. I know that I get a negative sign and a positive sign, but I do negative sine times sine, you get negative sine squared. All right, well, 1 minus sine squared by our Pythagorean identity is a cosine squared. So on the numerator, I still have a cosine times 1 plus a sine. Denominator, I use my Pythagorean identity to say this is cosine squared. Now hopefully you're kind of seeing, hey, maybe I can cancel out one cosine here with one of the cosines in the denominator. What that makes left is 1 plus the sine of y all over the cosine of y. Now here's where I can start splitting stuff up. Again, I know I'm going to have a plus sign, so I have a plus sign here. And I need secant. Secant's the same thing as 1 over cosine. Hey, look, I can split this up. So I can split this up to 1 over the cosine of y plus the sine of y over the cosine of y. And what I end up getting then is the secant of y. Let me try that one again. The secant of y plus the tangent of y, which is exactly what I had on the left side, the secant of y plus the tangent of y. And again, we'd like you to work with only one side at a time. There are going to be times when you have to do both, but the goal is, if possible, to work with one side only at a time. Now, let's flip the page and look at a couple more. Again, the biggest thing, practice. Practice is going to be the biggest thing, and you've got to try something. Now, take a look at number 5. Number 5 is just, I think, overall, just kind of bad, because you're looking at the fact that both sides have to have fractions, so both are equally difficult. So here's what I'm going to do. I'm going to just try and mess around with a few things. I'm going to look at the right side first, and I'm going to still draw my line, but I'm going to look at the right side first, because I know on the right side, I can split this up. So what I have then is 1 over sine minus a sine over sine. And maybe this will help get me, I don't know, some nice answer that I know I'm supposed to get to. I'm playing around here. Take a look. 1 over sine is the same thing as the cosecant. Minus sine over sine is the same thing as 1. Well, now the cosecant minus 1 looks way better, at least, than what I started with. So I don't have a way, though, to simplify that, because I need a cosecant squared to use a Pythagorean identity, and I only have a cosecant. So I'm kind of stuck here. So let me try the left side and see if there's any way to make this better. What I'm going to do, because I have cosecants here and I have a cosecant in the denominator, I don't have cotangent anywhere. So my goal is to replace the cotangent squared with something else. Well, I know there's an identity that says 1 plus cotangent squared equals cosecant squared. Sorry. So can I replace this? Well, yeah, if I move the 1 over, then cotangent squared is the same thing as cosecant squared minus 1. Then at least I have all cosecants, although I may not like it, it at least is better. Now I still have this 1 plus on the bottom, and when we had something on the bottom, we did a conjugate, and you could try a conjugate here. It ends up being a little messy. What I can do, though, is factor, and this may not be something you're thinking of, and so this is kind of our big trick for this one. I can factor a cosecant squared minus 1 because it's a difference of squares. So if I factor it, I get cosecant minus 1, and I get cosecant plus 1. And I put it over 1 plus cosecant. And I hope you see why we did this, because if you look, I can now cancel a cosecant plus 1 and a 1 plus cosecant. The order of the addition doesn't matter because addition is commutative, but they have the same term, so I can cancel it. Hey, look, what I'm left with then, on this side, I get cosecant minus 1, and on the right side, I get cosecant minus 1. And the biggest hint in this case, 1, we had to work with both sides, but 2 is we were able to factor this cosecant squared, and that's really what kind of helped us work with that fraction on the left. And again, a lot of times you're going to have to mess around with things, but it's really this idea of, hey, can we give it a shot? Okay, try a few things. There's other ways to do this. This is the easiest, but really you got to play around with it to be able to figure this stuff out. one last one before we look at a couple other ones. And actually, you know what? I'm going to ask, well, let me finish. Okay, take a look at the sixth one. Sine cubed times cosine to the fourth equals cosine to the fourth minus cosine to the sixth quantity times sine of x. Okay. Which side is worse? In this case, we look at it, I think the right side is worse. So I'm kind of looking at, okay, what's my possibility? And this is kind of a different way of doing things. But here's what I'm going to do. If I look at the right side, I'm going to start just with this chunk, okay? And if I look at this, what I'm going to do is say, okay, is there anything in common? Well, yes, I can take out a cosine to the fourth from each of them. And if I do that, I'm left with 1 minus cosine squared. And then I have this extra sign out there, and that's fine that that extra sign just kind of stays. And now I'm looking at this, is there anything I can do with that 1 minus cosine squared? Because I have the cosine to the fourth, so that's a good thing. I only have one sign though when I need sine cubed. Ding, 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 ding. Hopefully, you know that this is part of that Pythagorean identity. 1 minus cosine squared is sine squared. So I have cosine to the fourth times sine squared times another sine. Well, sine squared times sine is sine cubed, and then I have this cosine to the fourth. So I have sine cubed times cosine to the fourth. And this ends up being one of the nicer ones you can look at and say, okay, I can pull something out. So we're really working with factoring idea with a greatest common factor. Now, here's what I'm going to do for the next couple. It says practice on your own, okay? In order to get the points for your notes for this section, you must have an attempt on all four. On all four to get notes points. Okay, so in order to get points for the 5-2 notes, you have to have a valid attempt on the bottom four. Now, some of them are things we've kind of covered, some of them take similar ideas, some of them you really just have to play around with. But I will not give you points for the 5-2 notes unless you have a valid attempt on all four of the ones at the bottom. Okay, so that's the end of my lesson for section 5-2. Again, you've got a little bit of homework before you get to class. We're going to start class with these four, but again, you're not going to get the notes points unless these four have an attempt on your notes. So, thank you for watching. That's the end of section 5-2.